Okay, so going over our Unit 1 study guide for quadratics and solving quadratics, starting with complex numbers. Complex numbers are written in the form A plus BI. Sorry, I have a thing covering that up, so I can't write it there. Where the A represents the real part and the BI represents the imaginary part, and the I is equal to the square root of -1. So our complex and imaginary numbers come from the square rooting a negative. Simplify each of the following to one of the values in the cycle. So this is your pattern of I is equal to I squared is equal to -1, I to the third is equal to -I, and I to the fourth is equal to 1. So when you're asked to simplify these large powers, you're going to take the exponent and divide it by 4 because there are 4 parts in our pattern. So 21 divided by 4 is 5.25, which would be the same as 5 1/4. So we go through our pattern 5 times and then we make it 1/4 of the way through. So I to the 21st power would be equal to I to the power of 1, which is just I. Okay, for 309, or to the power of 319, so we'll take 319 divided by 4. We get 79.75. So that would be us going through the pattern 79 times, and we make it 3/4 of the way through it at the end. So we end on I to the third, which we know is equal to -I. Okay, next we have 622. 622 divided by 4 would be 155.5. So 0.5 would be the same as 2/4. I know that's not a simplified fraction, so that would be 2/4, but I need it with a denominator of 4 to show like how far we made it through that next part of the pattern. So we made it to the second part, which would be I squared, which is equal to -1. Okay, then I to the 1,240. I'm going to take 1,240 divided by 4, and I get 310. This means that I went through the whole cycle, technically 309 times, and then I made it all the way through that last cycle to make it 310. So this would be equal to I to the 4th, which is equal to 1. So whenever you have a decimal of 0.0, your answer is going to be a 1. Whenever you have a decimal of 0.5, your answer is going to be a -1. You have a decimal of 0.75, your answer is a -I. When your decimal is 0.25, your answer is I. Number 3, write the expression as a complex number in standard form. So just simplifying and combining like terms. For A, there is a -1 in front of that parentheses. There's a +1 in front of the first parentheses. Distributing a +1 does not change the values, so we're just going to drop the parentheses. Then we distribute -1 times -2 is a +2. -1 times -9i is a +9i. Combining like terms, 3 plus 2 is 5, 6i plus 9i is 15i. Part B, these both have coefficients of +1, which isn't going to change any of the values when I multiply by a +1. So I'm just going to drop the parentheses. So we're just left with 1 minus 8i plus 3 minus 2i. Combine like terms, 1 plus 3 is 4. -8i minus 2i is a -10i. Part C, we need to distribute this negative, which is really a -1. So we have 3i minus 2 minus 4i, and then 3 times 4 is just 12. from here. Combine like terms, we like to do our real numbers first. -2 plus 12 is 10. 3i minus 4i would be 1i, or you can just write I. Reduce the expression 3i times 3i squared plus 4i cubed minus 2. I would first start with simplifying your exponents wherever possible. So the 3i stays the same, but we know I squared is equal to -1. So instead of having I squared, we're going to have a -1. We know that I to the third is equal to a -I, so I'll have a +4 times a -I, and then -2. So all I did from the original question to this first line is I changed I squared to -1 and I to the third to a -I using that pattern. From here, we're just going to simplify. 3 times -1 is a -3. 4 times -I is a -4i, bring down the -2. Okay, continuing to simplify, I need to multiply 3i times -3 would be a -9i. Bring over the -4i and bring over the -2. So combine like terms, -9i minus 4i is a -13i, and I just carry over the -2. Next, number 5, true or false? 2i plus 6i equals 2i times 6i. Well, to make this proof, we're going to simplify the left side and simplify the right side. We know that 2i plus 6i is 8i. And 2i times 6i, well, 2 times 6 is 12, and I times I would be I squared, which we know that I squared is equal to -1. So this is really equal to a -12. So this would be false. And the explanation would be me showing my work. Number 6, multiply and write in standard, I should say write in standard complex form. So we're going to multiply these out and then combine like terms. Standard complex form is that a plus bi. So you like the real number first, followed by the imaginary. So we're going to start by multiplying. 3 times 2 is 6. 3 times -I is a -3i. Then 4i times 2 is a +8i. And 4i times -I is a -4i squared. Combine like terms. -3i plus 8i is a +5i. And we know that I squared is equal to -1. So this would really be -4 times -1, which is a +4. So last, we need to combine. 6 plus 4 is 10 plus 5i. Part B, we have 1 plus 3i squared. So this whole binomial expression is raised to the power of 2. So I need to multiply the binomial expression times itself. The whole expression being raised to the power of 2 means I have to multiply the whole expression times itself. Then we multiply. 1 times 1 is 1. 1 times 3i is 3i. 3i times 1 is 3i. 3i times 3i would be a +9i squared. Let's see, we know that, bring down the 1. 3i plus 3i is 6i. We know that I squared is equal to -1. So this is really 9 times -1, which would be a -9. So we combine like terms. We have 1 minus 9 is a -8 plus 6i. Part C, still multiplying. These are complex conjugates, which means that they are the same real part with opposite signs on the imaginary parts. Okay, so they both have a positive 5, and then we have a negative 2i and a positive 2i. So with that being said, complex conjugates, when you multiply them together, the i's cancel. So the imaginary numbers cancel away. So you really only need to multiply the first times the first of each binomial and the last times the last. So 5 times 5 is 25. And negative 2i times positive 2i. A negative times a positive is a negative. 2 times 2 is 4. I times I is I squared. If you would rather multiply this out, you can do that just like we did here, and you'll get the same exact answer. Next, we want to keep simplifying. We know that I squared is equal to negative 1. So this is really 25 minus 4 times negative 1. So 20 or negative 4 times a negative 1 is a positive 4. So our final answer is 29. Divide using complex conjugates. So we're trying to simplify these quotients by using complex conjugates to get the I out of the denominator. You're technically not supposed to leave any I in the denominator of a fraction. So the complex conjugate of 5i would technically be a negative 5i. Whatever we multiply by in the bottom, we need to multiply by in the top. And then to multiply these fractions, you're just going to multiply across. So 4 times negative 5i would be a negative 20i. 5i times negative 5i. 5 times negative 5 is a negative 25. And I times I is I squared. Reducing this, we know I squared is equal to negative 1. So we have negative 20i, and then negative 25, and we know this is a negative 1. Negative 25 times a negative 1 would be a positive 25. And the last thing we would need to do is reduce that fraction. 20 and 25 can both be divided by 5, so we'll reduce that. Negative 20 divided by 5 is a negative 4i. And 25 divided by 5 is 5. Part B, the complex conjugate of 2 minus 3i would be 2 plus 3i. Then whatever we multiply by in the bottom, we need to multiply by in the top. So we'll multiply 2 times 2. So in the top, we need to distribute this out. So 2 times 2 is 4. And 2 times 3i is a positive 6i. In the denominator, we only need to do the terms that won't cancel, which are the first times the first. So 2 times 2 is 4. And the last times the last. Negative 3i times positive 3i is a negative 9i squared. So next, we want to keep simplifying. We have 4 plus 6i all over. I squared is equal to negative 1. So this will turn this into a 4 plus 9, because a negative 9 times negative 1 is a positive 9. So our final answer is 4 plus 6i all over 13. Part C, dividing 4 plus 2i over 3 plus I, multiplied by the complex conjugate of 3 minus I. So in the top, we need to FOIL this all the way out. So multiply 4 times 3 is 12. 4 times negative I is a negative 4i. 2i times 3 is a positive 6i. 2i times negative I is a negative 2i squared. There we go. In the denominator, just doing the parts that won't cancel. So that would be 3 times 3 is 9. And I times negative I is a negative I squared. So in simplifying, we have, lost my colors. I squared is equal to negative 1. So that's really a plus 2 in the top. 12 plus 2 would be 14. Negative 4i plus 6i would be a positive 2i. In the denominator, I squared is equal to -1. So that would be a negative -1, which is a +1. And 9 plus 1 is 10. The last thing is we need to reduce. We're going to look for anything that goes into 14, 2, and 10, which would be 2. So I'm going to divide each of these by 2 to reduce this fraction. So we'll get 7 plus I over 5. And part D, don't have any space, so I'm going to write on the left side. I want to multiply by the complex conjugate of 4 minus 3I. In the top and bottom. So in the top, we do the full FOIL. We have 4 times 3 is 12. 4 times 2I is 8I. Negative 3I times 3 is a negative 6I. And negative 3I times 2I is a negative 6I squared. In the denominator with the complex conjugate, just going to multiply 4 times 4 to be 16. And negative 3I times positive 3I is a negative 9I squared. So in the numerator, let's see, this negative 6I squared will really become a +6 when I multiply that I, or change that I squared to be a -1. Negative 6 times -1 is a +6. And 12 plus 6 is 18. Then we have 8I minus 6I is a positive 2I. Then we want to, let's see, change this to a +9. And 16 plus 9 is 25. Okay. Number 8, we're solving for our complex, solving for your unknown variables. When you have a complex number equal to another complex number, you know that their real parts are going to be equal to each other. So the real will equal the real, and the imaginary will be equal to the imaginary. So the A will equal the A, and the BI will be equal to BI. So you can just rewrite your equation as A equals A and BI equals BI. Now, the problems we have here, we don't have A's and B's. We have actual coefficients, but the idea is the same. I'm going to set the real number equal to the real number. So we have 5x equals 10, and the imaginary number equal to the imaginary part. So that would be 3I equals a negative 6yi. From here, solving for x, I would divide both sides by 5 and get the answer of x equals 2. For part A, let's see, we want to solve for y. So I want to divide out a negative 6i. So let's see, the i's would become a 1, they would cancel, and 3 divided by a negative 6 would be a negative 1/2 equals y. So both of these would be my answer. Part B, set the real equal to the real. So a negative 3 equals 51x. Then we want the imaginary equal to the imaginary. So we'll have 28i equals 7yi. So solving for x, we want to divide both sides by 51. So we get a negative 1/17, because 3 divided by 3 is 1, 51 divided by 3 is 17, and that equals x. Then on this one, we're going to move things away from the y. So I'm going to divide by 7i. We're just left with y. 28i divided by 7i would be equal to 4.